You let me know when, and this advances it, the arrow to the right, that one. Yep. Okay.
Can you do an intro, or are you?
It's up to you. I can just go.
Okay,
go ahead.
go ahead.
Yeah. Well, good evening, everybody. Welcome to the Marshall W. Allworth Planetarium. My name is Eric Norland. I'll be giving the presentation this evening, and I'm a member of the local astronomy club, the Arrowhead Astronomical Society. So when I was a little kid, about 10 years old, I went out in the backyard under a clear, dark sky with my grandpa, Norland. And I said, Grandpa, what are stars? And he said, they are pinholes in God's great blanket. And that stuck with me for a long time. I kind of imagined God glowing like a light bulb underneath a blanket with holes in it. What a blanket it would have been. And kings and gods were born from stars in ancient times. The symbol of Judaism is the Star of David. Jesus was born beneath the Star of Bethlehem. Islam's symbol is the crescent moon and a star. And Caesar's star may have been a comet. And comets were kind of bad omens. Just before sunrise, a bright star appeared in the east, and the Buddha achieved enlightenment. Underneath the Bodhi tree, there you can see the star right there. This is the Bodhi tree. There's the Buddha receiving nirvana and enlightenment. But the devil was nearby, and that's Mara right here with all these temptations. But it involves stars. The word disaster is from disastar, blaming stars for creating havoc. Bronze Age man may have thought stars were angels, and they twinkled because of their flapping wings. And there's a lot of ancient sculptures that show angelic-like creatures with wings. And here's one with the many different stars. It's depicted. The wheel is the year. Many stars are named for parts of the constellation. Like Betelgeuse means the armpit of the giant. Aldebaran means the eye of the bull. And Rigel means foot. So stars make up patterns in the night sky. An ancient man noticed this and gave them names. Like right here is Orion, the giant. Here's Betelgeuse, the armpit of the giant. Here's Rigel, the foot of the giant. Here's Aldebaran, the eye of the bull. And Sirius, the dog star, in the constellation of Canis Major. So stars can depict parts of the zodiacal creatures and the constellations. Here's the constellation of Aries, the ram, with the star Hamel. While stars may have been considered angels, the planets were thought to be gods. Mercury, the speedy messenger god, Venus, the goddess of extreme beauty, Mars, the god of war, Jupiter, Zeus Pater, or God the Father, Saturn, the god of the end of time. For a long time, up until the time of Galileo, about 1600, people thought that the Earth was at the center of the solar system and that all of the planets and the moon went around the Earth. And it was in about 1550 that Copernicus came out with a revolutionary idea that the sun was the center of the Earth. Here's the Earth as the center, again with the gods going around the Earth. Whoops, I pushed the wrong button. Here we go. So each of the days of the week then were named after the sun, moon, and planets. And Sunday is named after the sun, the most prevalent of the celestial bodies. Monday, the moon. Tuesday, Mars. Wednesday, Mercury. Thursday, Jupiter. Friday, Venus. Saturn, Saturday. Now, do you know the name of the star that is nearest to the Earth? Let's see. If you said the sun, you're right. That is a star. The sun is a star. The sun became the most important celestial body to early man. It provided warmth and light for safety. It seemed to follow you everywhere you walked. And it was hard to hide from it during the day. There may have been a tendency to want for the sun at night and to cry out for it because it was dangerous at night for early man. They didn't have lights and it was dark, and there were creatures that preyed on man. It's possible that that's some of the earliest origins of prayer, wishing that the sun would come back. They wondered, where did it go at night? Why did it leave? What made it move across the sky? Well, people tried to figure that out, and the Egyptians believed that the sun was like a god. It gave information. It sent it out in rays to the pharaohs. Mithraism is based on Mithra slaying the bull of heaven. Long ago, people believed that a woman and her menstrual cycle were like the moon, 29 period or 29 days to a cycle. So they related woman to the moon. And most women names are part of the namesake of the moon, like Cynthia or Luna. And the Romans would worship the invincible sun from 100 AD. Stonehenge is a solar or a sun temple. So to early man, the sun was really important. Here's how Stonehenge works. On June 21st, the sun rises and the light of the sun kind of shines down between these two stones into the temple of Stonehenge, and it illuminates this altar stone. And that would tell them that it was June 21st. They could reverse it by watching where the sun set on December 21st. So it was important to them to keep their calendar straight. So what makes the sun move? They came up with this idea that a team of horses pulled a chariot with Helios, the sun god, across the sky. This is a place I visited once. I stood right down here, but the statue was gone. And this is the Colossus of Rhodes, an island off of Turkey, where there was a huge statue of Helios. It was about 150 feet tall, made out of metal. And it was to the sun god Helios, one of the 7 wonders of the world. And did you know that the Colosseum had one too? Here's the Colossus of the Colosseum. That's how the namesake Colosseum came, because the statue of Helios was just outside of the Colosseum, and it was huge. The Hindus have a sun god called Surya up here, and he's pulled across the sky by teams of horses. In Machu Picchu, there is a altar stone that on a certain date, like December 21st, when it's their first day of summer, the light of the sun comes right upon the altar stone, and they would sacrifice people to the sun in hopes of keeping it shining. You think that worked? So there are 8 named planets now of our solar system. Pluto has been kind of demoted to become a dwarf planet or a subplanet. And it takes about 40 minutes for light to make it from the sun to Jupiter, or from the Jupiter to the Earth. About an hour and 20 minutes from Saturn to the Earth. 2.7 hours to arrive from Uranus and 4.3 from Neptune. So it's a big solar system. The Egyptians had a god named Ptah, and that's what the name Egypt came out of, Ptah. And he was the morning sun, the rising sun. Sekhmet was the noonday sun, and Hathor, the setting sun. Hinduism has something similar. Brahma is the rising sun. Vishnu is the noon sun, the preserver. Shiva is the destroyer, the sunset. There are monuments in Peru dedicated to know where the sun set on June 21st, like here, in December 21st, so they could keep track of their calendar. And Hirohito was considered the living sun during the time of the 1940s. People were not even allowed to look at him. He was so sacred. So humans have come up with a lot of different ideas about the sun. And one of the most spectacular things to witness is a total solar eclipse where the moon covers the sun. And you can see Bailey's beads, or the solar corona, the crown of the sun. And that was incorporated into the story in artwork of Jesus. And here you can see Jesus with the corona, and 12 disciples, like the 12 zodiacal signs, and 2 fish connoting Pisces, the zodiacal sign of Pisces, which at the time of Jesus, the sun moved into Pisces. Here's another one with the corona. Here's the fish. And here's Judas over here with a knife, ready to do his deed. So, well, that's folklore. That's mythology. That's in the past. But what really is the sun? Well, it's a star, of course, and it's made up of hydrogen mostly, and undergoing fusion. There's a difference between fusion and fission. Fusion is when an atom bumps into another atom of hydrogen and fuses under extreme temperature and pressure. Fission is when you split an atom, and that's not what's happening in the sun, it's fusion. So these are the parts of the sun: the deep core, the radiation zone, convection zone, the photosphere, and sunspots. But there's a little bit of a problem here. You see, on Earth there is gold. And where does gold come from? The sun doesn't make gold. The Earth doesn't make gold. Here's where the sun is right now, about 26,000 light years from the center of the Milky Way. But before the sun, there was another star, a big star that went supernova. Now, here is the sun right here, I believe. I can't quite read it. And here is the star Sirius. Here's the Sirius compared to Aldebaran. And here's Aldebaran compared to Antares. Here's Antares compared to VV Cephei. So these are the stars that become supernova. They're huge. If you put them where the sun is, they would go all the way out to Mars, even beyond. They're big stars. And they burn up fuel quick. Here's the sun, like an average star. It'll eventually, in about 5 billion years, swell up into a red giant, puff off its outer atmosphere, leaving a planetary nebula and a white dwarf. But a big star, a massive star, will swell up into a red supergiant and go supernova. And it will leave behind a neutron star or a black hole. So there was a star before the sun that went kablooey, and it blew to smithereens. But under those kinds of temperatures, things ultimately that are heavy elements are created. And here's gold right here, AU. And it was underneath a supernova kind of event. And silver is one of those elements too that was created, and iridium and some other heavy elements are created by a supernova. So if you're holding a piece of gold or you got a gold tooth, remember where it came from a cosmic event that happened before the sun was shining. So now a supernova can turn into a black hole and become a singularity. But a singularity is also what the Big Bang, the origin of our universe, is believed to have begun as a big bang, and out came the new universe that we are a part of now. And if you go back to about 1 billion years ago, it says gravity makes hydrogen and helium gas. Here it is again. 1 billion years ago, hydrogen and helium form big stars. So here's the early origin of the universe about 1 billion years after it started with the Big Bang. Here's these big stars. These are monsters. And you can see the sagging of space and time. And actually, that's depicting compression. Gravity is pushing hard against the star, and they don't live long. They use up all of their fuel, and they go supernova. Kablooey! They blow to smithereens, and they become black holes and neutron stars. The sun doesn't sag space that much because it's not that heavy compared to those stars. So they started the origin of galaxies. Here's the first stars. Here's the Big Bang, about 1 billion years in. First stars, then black holes and galaxies start to form. Every galaxy is believed to have a black hole in the center, and they're expanding. The universe is expanding out. So now we have the sun in this position. And what is the oldest star in the sky? Whoops. Believe it or not, we can see that star almost every night. And it's hypothetical, it's theoretical, that Arcturus is one of the older stars, about 8 billion years old. And here's the sun in comparison to Arcturus. It's a big star. Here's where Arcturus is located. Here's the Big Dipper. Here's the arc of the handle of the Big Dipper points to Arcturus. And about 6 billion years ago, another galaxy merged with the Milky Way. It passed through it. And it is hypothetical, but it is believed Arcturus was dropped off. And some of the globular clusters maybe were dropped off too. And this also excited star formation. It kind of energized the galaxy, the Milky Way. Here's the Milky Way. Here's this other galaxy coming in. Imagine it drops off Arcturus, and it starts star formation and creates the sun, the new star that eventually becomes our solar system. So here's the sun comparison to Jupiter. Here's the Earth. We live on an 8,000 mile in diameter world. The sun is nearly 1 million miles, 875,000 miles. So we live in this very tiny little world. And now, like I said, there's some big stars out there. Here's the sun right here compared to VV Cephei. And there's even bigger ones like Scuti, a really huge 1,700 times larger star than the sun. So the sun originated in a little bit of a nebula where stars are born. And then there's these Bach globules or little nurseries for stars, and they get more pronounced and more defined over time. Places like the Pillars of Creation in the Eagle Nebula are where stars are born in the Orion Nebula. So enough hydrogen starts to form and debris from the supernova starts to accumulate around the star, starts to begin its process, and planets start to develop. Lots of impacts occurred in the origin of the early solar system. We know that Earth was hit by a hypothetical Theia, another planet, which also created the moon out of that collision. And the other planets are created from this, the clearing out of the solar field and creating a solar system. This just showing the expansion of the clearing out process around a star. It pushes out and creates planets. And here's some of our neighbors in space. Here's the sun. Sirius is our neighboring star 8 light years away. Alpha Centauri, like 4 light years away. Those are our next door neighbors. But what's really interesting, quite amazing, is they've figured out that the sun was born with brothers and sisters. But where'd they go? The galaxy has moved enough that they now believe the brothers and sisters are in M67, a cluster of stars, and that is located in this area of the sky, Cancer, where M67 is. I just think that's amazing. The sun has some brothers and sisters out there. So how do stars work? Well, there's an equilibrium going on between gravity pushing in and fusion pushing out. And if there's enough fuel, a star will stabilize and just kind of go along its merry way. Oh, I got a slide there. I'm not sure what it is. But stars are very busy. The sun is very busy, that is. And here's a prominence. The Earth would be like this red dot. These are huge areas of ejection of some kind of energy from the sun. A CME, it's called a coronal mass ejection. And that's what helps create the northern lights. Well, here's a sunspot in comparison to the size of the Earth. So we are dwarfed by the mega sun, the hugeness of it. And we were just talking tonight that there is no probe that can go inside the sun and tell what's going on in there. It's all purely physics and mathematics, things like that. Here's the size of the Earth compared to a prominence. You know, this would just vaporize us. And I'm not going to pretend to be an expert at what's the physics of going on in the sun, but about 500 million tons of hydrogen is being fused every second, and about 495 million tons of helium is being fused or being created at the same time. The missing 5 million tons is pure energy. So, well, I won't again try to elaborate too much, but here we show 2 hydrogen atoms creating deuterium, and these are isotopes, positive and negative neutrons. And it actually takes 4 hydrogen atoms to create 2 or 1 helium atom and give off some energy. So, well, maybe that's something you can study in physics. But again, a lot of hydrogen is, every second is being fused to create all of that energy. The sun is called a G2 star, or it's a white star. And at the core of the sun, it's about 27 million degrees Fahrenheit. The photosphere, this outer region, is about 10,000 degrees Fahrenheit, or very similar to the center of the Earth temperature. So it's very hot. Here's the core, like 27 million degrees. And it takes a light photon, when the fusion occurs, 10 to 100,000 years to make its way up to the surface, and then it takes 8 seconds to get, or 8 minutes to get to the Earth. So once again, there's the core, the radiative zone, the convective zone, and here's some sunspots and some CMEs sending out energy towards the Earth. Now, every 11 years, the sun kind of wraps up with its magnetic field lines, and creates a lot of sunspot activities. And then it kind of fades away and calms down, and it goes through this cycle. Now, some stars, now again, the sun turns in about 25 days. It does a rotation. But stars like Regulus spin really fast. It rotates once every 16 hours. It rotates so fast that it becomes oblate. And that is fast for a huge star. It's a lot, here's the size of the sun compared to Regulus. So some stars move, rotate really quick. And here's just showing sunspots on the sun. And then here's using more of like infrared technology to show where the sunspots are. So this one is this one. This one is this one. And just to give you some idea of the activity on the sun. So the sun is 99.8% of the mass of the solar system. And there's a lot of energy being consumed to keep the sun working. Eventually, the sun will, or a star will burn off all of its hydrogen, then start fusing helium, carbon, neon, oxygen, silicon, and iron core can't be fused. And that will cause the death of the star. Now, this is called the HR diagram. And the sun is right about here. It's just an average star, a kind of a dwarf, white dwarf, they call it. And some stars are super giants. They're way up here. They're huge. And they're blue. They're really hot. There's others that are cooler. They're red. And then there are stars that are small, like white dwarfs, which are hot but small. And stars can move into different areas of the HR diagram. So here's a prominence again. And there's filters that fit on telescopes so you can actually see some of these things. But some of the things that happen on the sun have an effect on Earth. And we see northern lights because of coronal mass ejections coming and exciting the magnetosphere and the chemical elements up there above the Earth. So the life cycle of a star like the sun is that, and here's where it is right about now, right there. In about 5 billion years, it'll swell up into a red giant, puff off its outer atmosphere, and leave behind a white dwarf. And there are stars that are millions of times bigger than the sun, called hyperstars. So about 1,300 Earths could fit inside Jupiter. 1,000 Jupiters could fit inside the sun. And about 10 billion suns could fit inside a superstar like Stephenson 218. There's many different subject matters that deal with stars, like black dwarfs or subgiants, eclipsing binaries. And that's something that a person can research. Giant stars, pulsars, yellow dwarfs, variable stars, neutron stars, brown dwarfs, many different kinds of stars. So just imagine when you go out and look at the stars, those are the same stars and the same sun that the dinosaurs saw. Little has changed in 65 million years. And the sun will eventually swell up and it will engulf the earth. And everything that has lived or died and goes into the soil on the earth, even if it's cremated and goes up in the atmosphere, it settles down on the earth, will be consumed by the sun. And then the sun will shed it into the universe by leaving a planetary nebula and a white dwarf. And everything will return back to the universe. It's like the great recycler. So I hope you've enjoyed the presentation. Any questions? Well, I hope you enjoy seeing the sun tomorrow. Thank you very much.